Alright, so let's talk about this problem. See what we know and what we don't know. Alright, what's different about this is our first look at springs. So you can see in the shadow here that there was an original position of the system unloaded. So with no loads on it, we assume that most of these are this is the unstretched length of these springs. We add these cylinders to it, and you can see it causes the system to move down an S value or a sag value of half a meter. So you have the original geometry of the system. It's very symmetric. You'll notice that the angle, the 1.5 to 2, which is really a 3 to 4 slope, is the same for both. And it's just 1 meter gap in the middle. And also to help us out, the spring constants are both 100 Newton per meter. So first thing we should probably do is find the original length and then how much the spring stretches. Remember that the force in a spring is the stiffness times how much it displaces to sag. So what is that sag, or what is that elongation going to be? So let's find that first. So we know originally, say S naught, we had, what's the length of this? Originally. Yeah, it's 2.5. The reason I know that is because if you multiply these both by 2, you get 3 and 4, and that would be a 3, 4, 5 triangle. And if you divide it by half, 5 divided by half is 2.5. But you're right. If you don't see it, just take 1.5 squared plus 2.5 squared, add them together, take the square root. You should find that the original length is 2.5 meters. Everybody see that? Now we'll have to find the new length. I don't know that off the top of my head, like the other one. So what we have now is we have a length where in the X direction it's 2 meters, and in the Y direction it's what? Well, it's 1.5 plus a half. It's 2 meters. All right? That's the sag. So what's the length of this line going to be? Okay, L. Yes. 2 times the square root of 2? Is that what it would be? No. Square root of 8, you say? Yeah, which is 2 times the square root of 2, right? I'll just write it like that. Which is, either way, somebody compute that. 2.82. And that will be meters. So therefore, our S value will be the final length minus the original length. So that's how much it will stretch. So that means that the force in this cable AC is going to be equal to what? Right, it'll be exactly. It'll be the stiffness 100 newtons per meter times whatever that is, 0.33, which is equal to what? Yeah, why don't you guys carry this out to a few more decimal places? I think it's, isn't it? Oh, I got something different. No, but I mean, when I did this, maybe I got a different value here. What's the square root of 2 times 2 divided by that? I think it's 0.33. It's probably 0.32 something something. Let's be a little more precise. What was it again? Okay, 32.84. That's better. Just want to get a little more precision, and that should be Newton. So we know the force. Now it's just using what we knew about our spring. So what would be the weight of the cylinder? Well, now I can actually come down here and draw a three-body diagram of point A. So here's point A. What's acting down is, let's just call it weight. I have a force horizontally, which would be the force AB. And then I have this force that I just solved for, force AC. And what was the angle here? Oh, we know it's 2 to 2, which is 1 to 1. So I'll just draw it like this. It has a slope of 1 to 1. Did we see that? Can I write an equation just for W? I think I can. Who did I leave off on before? Who's the last person to answer? I don't remember any guy's name. Jones? Did I get to Jones? Mitchell? Oh, I did you. Mr. Wynn, did I talk to you again? Good answer. Mr. Tapp, are you out there? So, can I write an equation just for the sum of the forces in the y direction? What is it? I'll assume up is positive. And I'll ask you to assume up is positive. So what do you get? Correct. And what else? That's great. Do we know FAC? Yeah. So what's W? It looks like it's just that divided by the square root of 2. Now that's newtons. The problem actually asks for mass. So what's the mass? You have to divide it by 2.37, and that'll be kilograms. I think that's correct. Now, did I have to worry about AB? I did not. Now, if I wanted to know that, could I have solved for AB? Yes. I would just sum forces in the X direction. Because I already have the tension cable, remember, I already have this. So my two unknowns would be FAB and W, but the problem didn't ask me for that. Questions? No? Yes? All right,